CIDR for the VPC, right?
Correct.
Uh, yeah, but what I saw in our present configurations in our company, okay,
Uh-huh.
was that they were using a subnet as a part of the primary CIDR. So is that possible that we can use a subnet as part of the primary CIDR block?
Yes, of course. I mean, why are you saying it as a subnet? Because just because it's not maybe /16 or /24,
Right,
maybe it's
right, right.
/18, right?
It was slash 19.
Ah, you can do it. So I mean,
Okay.
we can't really say if it's /19. So we can't say that it's a subnet. It's a network. So
Okay.
/19 we can treat it as a network, and we can further subdivide this into, four subnets. In that case, each
Okay.
subnet would have a subnet mask of /21.
Right. So that the network is decide like as we know that there are three private IP addresses, right?
Yes.
So here, like, and that the address which I saw in our company, that didn't belong to any of these three private IPs. So is it like it is defined at the company level, like what will be the private IPs and all stuff?
Actually, it should belong to one of those three IP address ranges, because it can't be outside of it.
So one of,
Do
yeah,
you?
so the primary one was the part of the private one. Okay, I think
Okay.
192 something like that.
Uh-huh.
But there were secondary CIDRs also added. Okay, and those were like starting from 100 dot. So I'm not sure like how it started from and how it allowed, because when I tried to creating a VPC, okay, I
Uh-huh.
used 192 point something something, and then after that I tried adding secondary CIDR also, but I got error that it is an invalid IP address and all stuff.
Actually, I'm really surprised. It shouldn't be 100. There are possibilities of adding secondary CIDR. That's perfectly
Right,
fine, but it
right.
should normally belong to the uh, to the private IP address range. Do you know the complete CIDR block? What is it? Maybe it
It
is
was some,
IPv6 block. Are you sure that it was IPv4?
yeah, it might be IPv6. I'm not sure on that thing because I didn't saw that thing. Yeah, it might be 100 IPv6. Yeah, I'll check.
Yeah,
I'll
then
double check
we
it.
then there's no problem. If it's
Yeah.
IPv6, then we are going to discuss it separately.
Oh,
Uh,
okay, okay, okay.
that how to
Then
use
the
IPv6.
okay,
Yeah.
okay. That
So in
that was the,
IPv6, okay, that was the question, right?
yeah,
And
yeah.
there was one more question, Niyati, right? Can
Uh,
we use the same set of network in different VPC?
yeah,
Um,
yeah,
okay.
yeah. That was the
So
question. Yeah.
see, normally you shouldn't be doing it, uh, because then if they are in some separate regions, it's perfectly fine to use the same CIDR block in two different VPCs. But if at all, I mean, why to go for this? Because if at all, maybe sometimes people also like to keep a track. They draw this diagrams of their network architecture. This Microsoft Visio, and there are other tools as well. So if you keep the same IP address range, it would be a bit confusing. You will not know which network we are referring to, because both of them has the same CIDR block. Moreover, if at all for some reason you have to connect those two VPCs, you would not be able to do it, because there would be an IP conflict. So today we'll see that there is something called as VPC peering, using which we can connect two VPCs, and then instances running in both of these VPCs can connect to each other over their private IP addresses. So if we are using the same IP address range for both VPCs, then VPC peering would not be possible, and there you might get some issues if you have some connectivity with your on-prem environment. But
Okay.
technically, it's possible to create VPCs with the same CIDR block.
Okay. Okay.
So, any other questions? No?
No,
No, I think we are good.
we
Yeah.
are good. Yeah.
Yes, Shubham.
Okay. So, you guys can see my screen, right?
Yes.
Yeah.
Yes.
Okay, great. So, let's start with the VPC peering first.
Hmm.
So today we'll discuss what VPC peering is, what NAT gateways are, and then we'll discuss about user data, instance metadata URL, where where they might be useful, and then we'll see what elastic block storage is and what type of EBS volumes we have, and then we'll discuss about EC2 Instance Store and how to take EBS snapshots, and we'll see that they have incremental they are incremental in nature, and we'll also see how we can create our own custom AMIs today. So let's start with VPC peering. So a VPC peering connection is a networking connection between two VPCs that enables you to route traffic between them using private IPv4 addresses or IPv6 addresses. Instances in either VPC can communicate with each other as if they are within the same network, and we can create a VPC peering connection between our own VPCs or with a VPC which is in other AWS account. It doesn't necessarily have to be in the same AWS account. So cross account VPC peering is also possible, and we'll see that two VPCs that we want to peer, both of them can be in the same AWS region, and they can also be in different AWS regions. Earlier, I think few years back, this inter-region peering was not an option. So you can only peer VPCs which are in the same AWS region. But now it's possible. Even say for example, if you have a VPC in Asia Pacific Mumbai, you can peer it with a VPC which is in maybe Tokyo region. And what could be the advantages of that? The advantages are that traffic always stays on the global AWS backbone and never traverses the public internet, which reduces threats such as common exploits and DDoS attacks. And inter-region VPC pairing we already discussed, right? It's a simple, cost-effective way to share resources between regions or replicate data for geographic redundancy. So I mean, maybe say for example, you want to achieve something like, uh, I mean, say for example, even if an entire AWS region fails, you are considering that my site or my infrastructure would still be running, or my data would still be available in some other AWS region. So if you want to achieve that level of redundancy or availability, say for example, if something happens to the entire AWS Asia Pacific Mumbai region, you want that your data is replicated to some other region also. So in that case, what you can do is, maybe if you have a primary DB running in Asia Pacific Mumbai, uh, then you can run some secondary DB in some other region which is closest. Could be maybe Asia Pacific Singapore, and then you have a secondary DB running in AWS region Singapore, and then you can peer those VPCs, and then you can do that log shipping. So that log shipping would be happening over AWS backbone network. It doesn't traverse the public internet. uh, so that has two primary advantages. One is that it is more secure, and the other is that you get a reliable, better bandwidth as compared to the public network, which is internet. So this is how it looks like. So we have VPC A, which is 10.0.0.0/16, and then we have VPC B, which has a different CIDR block, and we can pair these VPC together. And now this instance which is running in VPC A, it can connect to instance running in VPC B, and this communication that is happening between the two instances, that will be over a private network, which is basically AWS managed network. So any doubts what VPC peering is?
When you mentioned that it can be with
across with different CIDR blocks, that means that uh, it can be anything. That it doesn't matter which CIDR block it is residing in currently. I'm asking this because previously Niyati had asked the question, because if both are having the same CIDR block, then what will happen?
I mean, of course, it's not going to work. So it is a mandatory thing that the cider blocks should be different. If the cider blocks are same for both the VPCs, we can't peer them. So peering is not an option in that case. It is not possible to do a peering connection between the two. So it is mandatorily have to be different. Cider blocks have to be different.
Okay. Okay.
Okay. So let's try doing this. So I think somebody tried to create a
So
VPC in
Shubham,
some other region, right?
yeah, it was Salman. So Shubham, I have one question.
Okay.
As you say, uh, the data which is getting pulled will be from AWS backbone, right?
Yes.
So it could be like whatever the amount of traffic we are going to pull, the bandwidth will be different from our local internet, right? Because
Yeah, of
there,
course, because see both the
because
VPC they are running
yeah.
in AWS infrastructure, right?
Hmm,
So I mean it is independent of our internet bandwidth because
hmm,
both of them resides in AWS infrastructure. It's just that these two machines or these two VPCs, they are in different AWS data centers, and those data centers are basically very distinct apart. They are in different geographic areas altogether.
hmm,
So even if they are very, I mean, geographically distinct, the good part is we are still able to connect using AWS private network, and we don't have to use internet. If we don't peer them, so then the only way to reach out to some other instance, say for example, I have a EC2 instance in VPC A, and then
hmm,
I have an EC2 instance in VPC-B. Both these VPCs are in different AWS region. Maybe VPC-A is in Asia Pacific, Mumbai. VPC-B is in North Virginia. Maybe it's in US. So now if instance A has to connect to instance B, then it has to go over internet, and both of them should have both of them should have internet connectivity. Basically both of them should reside in a public subnet, and both of them should have a public IP address, and then they would be able to communicate with one another, but the communication would happen over the internet. So internet is basically something which is unreliable, because internet is not owned by a single entity, so it goes through several organizations, and then no single entity owns this internet, and a lot of issues happens over the internet. And so so basically the bandwidth that you get, it's somewhat not consistent, and there could be security issues also, we don't know. So then so this is a good option to peer them, because then we are not sending traffic over the internet. So then we are sure that no organization is doing something like packet sniffing, or they are running some kind of traffic analyzer. If we are using some secure protocol, maybe it's fine. But if we are using some unsecured protocol, say for example, if you're communicating over HTTP, which is unsecured, it's not encrypted, then anybody basically uh, can tap in and might be able to decrypt that, or he doesn't even have to decrypt because it's plain text, it's unsecured protocol. Then he can basically capture those network packets and see what information is being sent by instance A to instance B. So all those things we can easily avoid using VPC peering connection, because it's a private network owned by AWS. So all sort of those possibilities are avoided. So does it make sense, or still any doubts around VPC pairing?
No, Shubham. It's just that the latency, there will be some latency, right? As the region, as far the region, the more the latency. Is that
Yeah,
the
of
thing?
course. Yes, of course. That is going to be a thing. So if you are peering two VPCs which are in the same AWS region, then of course you'll get a much lower latency. But if you are peering VPCs across regions, then you will see that you are having a bit of higher latency, but it would still be much better as compared to communicating over the internet.
Sure, sure. Thanks.
So Shubham, Salman here. So during the VPC peering, will it be the VPC available for the users or like it would be a downtime? I think it would be online, right?
Yeah, of course, it's online. It's a
Yeah.
complete online
Okay.
activity.
Okay. Just the latency part would incur to the users accessing those VPCs. Okay.
Yeah, I mean, even the latency is not that high. We'll see
Mhm.
that it's quite good actually.
Okay. Got it. Okay. Thank you.
Okay, so let's start. Um, so those VPCs are still there, or you guys have deleted those? The ones
No,
you
they are
created.
still there.
Okay, they are still there.
There, so Shubham, I deleted your VPC basically because yeah, it was giving this VPC limit reach. So while I was trying to create it in another region, so it probably said me like it would be chargeable for other services. So I rolled back to the Mumbai region and then I deleted
Yeah,
your
of course,
VPC.
it's fine. Actually, I was
Yeah.
surprised because I was thinking the limit is 5 and the guys are 4. So how come it's reaching? Because of course you can delete mine. So there's no issue.
So no problem. Okay.
Okay, so I am in North Virginia now. Okay, so let's try to create a VPC here quickly, and then we'll try to peer VPCs which are in Mumbai and a VPC that we are creating now in Virginia. So let's go to VPC. VPC. I will not be creating. I will not be creating 4 subnets here. Just 2 are fine, and you will see that this is totally private, and since it's private connectivity, we don't even have to attach internet gateway to this VPC. Okay, so let's
Right.
do this. So your VPCs,
So
create VPC.
okay, yeah. So Shubham, there would be the default VPC, right? We can use that for pairing. Is it to our custom
Yeah,
VPC?
of course.
Okay,
Yes, it's possible.
got
But
it.
let's leave it because I don't want to mess up the route tables of those.
Got it. Yeah.
Okay, so let's uh, we'll say
So
NV.
that gateway thing, or I gives me a, question. Is that the site which that day, the web server which we created, okay, and then we opened it in the browser, okay. So that gets on the internet, it gets opened through like whatever the request was to open that web browser, okay.
Mhm.
It goes to the gateway, and internally this our this a sub instance which is within the subnet connects to the gateway. Is it the correct statement, or like how it is?
Yes, it's a correct statement. So basically, any EC2 instances we will be launching in this VPC in North Virginia one, which doesn't have internet gateway attached. We won't be able to, first thing, we won't be able to install Apache web server also, because
Right.
when we'll execute this command yum install httpd, it's not going to work because yum would not be able to reach out to the repositories hosted on the internet where that Apache package is. So we won't be able to install the Apache web server, and then, and even if somehow we install it, then it would not be, even if we start it, since there is no internet connectivity, we would not be able to access it over the internet.
Okay, okay. So in that case, Shubham, this was we could install the Yum because of it had a connection with the internet. Okay, but
Mhm.
what happens in private subnets if if we have a database EC2 instance, okay, suppose, and
Mhm.
we need some packages to be installed for the database, to install data, to create a database or so anything. So what in that case, how can we install those packages?
So it's a very good question, Niyati. For that, we have NAT Gateway, and this we'll be doing it just after the VPC peering. We'll see what
Okay.
NAT gateways are and how we can give secure internet connectivity to instances running in private subnet.
Okay.
So the answer to that is NAT gateway. So we can do that using NAT gateway, and we'll see once we are done with this VPC peering.
Sure.
Okay, so
Sure.
let's start with so I'm naming this as NV VPC, North Virginia VPC, and I hope you guys have not used this cider block. Anybody is using this one?
Yeah, we haven't.
Okay, good. So no IPv6 cider block for now, and then let's do it. Create VPC. VPC creation is done. We'll quickly create two subnets here. Uh, what was the cider blocks? 172.17.
172.17. Yeah.
Okay, good. So create subnet. I'll create inside NVVPC, and then let's give this a name. NV NV
Subnet.
subnet 1,
Yeah.
and then availability zone doesn't really matter. So
This will be all private, right?
yeah, this
Both
will be all
both the
private.
private.
Just to
Yeah.
show you guys that this VPC peering connection is not something that relies on the internet, and the communication would be totally private. That is why I'm not attaching an internet gateway here. But
Hmm.
of course, if you have this requirement, if this VPC needs internet connectivity, you would basically create an internet
Public
gateway and
IP.
attach it.
Yeah.
Yeah.
Yes. Correct.
So as of now, let's create just subnet one, and availability zone doesn't really matter. So I'm putting it as no preference. And cider block, let's do 172.17.0.0/18.
Hmm.
So this is one subnet, and let's create another one. So this is NVVPC. Subnet name NV subnet 2.
Hmm.
Availability zone again doesn't matter, so no preference. 172.17.64.0/18. Create subnet. So this is done now.
Hmm.
No need to create internet gateway. I'll simply create a route table here. So I'll say route table NV route table VPC. I'm creating this for NV VPC, and that's it. Create route table. And as of now, I'm not doing anything. I'll simply associate this custom route table with the subnets that we created. So edit subnet association, and I'll attach this route table with these two and save associations.
Hmm.
Okay. So now let's go to Mumbai region. Okay, North Virginia. I'll switch to where is Asia Pacific Mumbai. Okay, here. Then we'll go to VPC,
Hmm.
and now what we are going to do is your VPCs. Okay, so let's use Niyati's VPC, and so what cider block it has? It is 192.168.24.0. Okay, good. So let's select this, and then we go to actions, and oh, I think it's not here. If we scroll it down, okay, so here there is this something called as peering
Hmm.
connections. Okay, so then I'll click on create peering connection, and then I will name this peering connection as uh, Mumbai to North Virginia. So select a local VPC to peer with. Okay, so this is the requester VPC. Basically, it is uh, the the VPC which resides in this region
This
that we
connect
want.
region. Yeah, which you
Yeah,
want to pair.
correct. Correct. Yes. So where is, I don't
Yeah,
Dev
see.
yeah, the
NVPC.
dev and VPC.
Yes.
Oh, then NV.
Second last. Yeah.
Yeah,
Okay.
this one. Yeah.
Okay. And then it asks whether you want to pair it with a VPC in this region or
No,
another
another
region.
region. Yeah.
So another region. And here also we have this option whether we want to pair it with a VPC which exists in our AWS account or with some other
Okay.
VPC in some other AWS account. If we choose another AWS account, you have to give the account ID here.
Hmm. Got it.
And an administrator has to accept that peering connection by logging into his AWS account. So I will say my account and I want to pair this current VPC with a VPC
Another
in
region.
another region,
Hmm.
and then we'll select North Virginia and then VPC ID of the acceptor. So here, if we go to VPCs, so this is the VPC ID of NV VPC. So I'll copy it and then I'll paste it here
Right.
and then I'll say create peering connection. So here, if we see the status would be initiating request to, this is our own AWS account, but
Right.
uh, if we refresh it, I think we will see pending acceptance by, this is our own AWS account. So we have to accept this in North Virginia region.
Hmm.
So if I go to North Virginia and then I navigate to again, where is that peering connections? Okay, peering connections. I'll see one here. This is
Pending
pending
acceptance.
acceptance. So
Right.
let's do that. We'll
Right.
accept it. We'll click this actions, accept request.
Hmm.
So
Accept
accept
request.
request.
Right.
So now it is provisioning and let's see once it is done. So it is active. The peering connection is active. So now let's try to launch one EC2 instance in North Virginia region.
So, Shubham, this peering activity, like it can be used for HA in case of databases, okay, and it can also be used our application servers can belong to one VPC, and they can connect to the databases in another VPC in another region. Is it possible like that?
Yeah, of course it is possible, but it would not make much sense because if application servers are in one VPC, why to keep databases in another VPC and that too in another region? I
Right,
mean, normally you would segregate this tiers as per subnet. So you'll have one subnet for application servers, one subnet for database
right.
servers.
Yeah, but
So
the only question was, is it is possible, right? Along with if we want to implement HA, we can do it through this. If you want to implement something, some architecture like this, it is possible, right?
yes, yes, of course. As long as the connectivity is there, I mean, of
Yeah,
course, so it depends if database servers are running in under VPC, then of course we have to peer them and test the connectivity because the
right,
one thing is connectivity from network perspective, whether there is a route, uh, whether basically there is a network route and your servers or the VPC router knows how to route network packets from application servers to database servers. So one is connectivity from network route perspective. The other
right,
would be from firewall perspective. So there is a network route, but there is a firewall in between, which is not letting the connections happen. So could be that there is a security group assigned to database servers, which is not letting the connections go, or there could be some knackles in between, which is stopping the connection. So all those scenarios we have to see. And
okay,
and and just a request, guys. I mean, don't leave your EC2 instances running because why to leave them running? Because it is chargeable. I mean, it is still under free tier, but I mean, we have 750 hours of usage. So if we keep running 4 web servers, it is going to run out of the usage. I mean, if we are going to do some lab which is not covered in free tier. It's perfectly fine, but it's just wastage. So it takes just maybe less than a minute. So we'll terminate it once our exercise or labs are done. Okay, so for now I am just
Sure.
letting this web server running because we have initiated a peering connection between the two, and we already have a web server running here. Now we'll launch an EC2 instance in North Virginia, and then we'll try to log into this Niyati's EC2 instance, and then we'll try to connect to EC2 instance running in North Virginia VPC. Okay, so
Sure.
let's go to North Virginia, and then I'll search for
So,
EC2.
Shubham,
Uh-huh.
multiple VPC can be paired to one VPC, right? Is- or is there any boundary or threshold?
I mean, no, it can be peered to multiple VPCs also.
Mhm.
But I mean, as these VPCs grow, then the number of VPC peering connections would be. There is a better service for that if you have multiple VPCs and you want to peer all you know like 5 VPCs in one region, 5 VPCs in another region. If you want to have connectivity, all kind of a mesh that each VPC should be able to connect to every other VPC,
Mhm.
then VPC peering connection would be hard to manage, and there is something called as transit gateway to deal it in a better way. If we have that sort of mesh connectivity, like 10 VPCs are there, and every VPC should be able to connect to every other VPC. So there will be whole lot of peering connections. So there is a transit gateway to do that, but to answer it, yes, it is possible to peer one VPC with multiple VPCs. Okay, so North Virginia region we are in. Now let's try to launch one instance here, and Amazon Linux 2 AMI is fine, and T2 micro is fine, of course, and configure instance details. I'll launch this in our VPC that we just created. Any subnet is fine, doesn't really matter. Both are private subnets as of now. And if you see auto assign public IP, it is disabled, and there's no point in assigning a public IP because there is no internet gateway attached. So even if we give a public IP, we will not be able to use it. And then that's it. We'll say add storage. This is just the default root volume is fine. And then configure security groups. So I will allow SSH from let's say from custom, and we can give Niyati's cider block here. So we'll restrict SSH access to the cider block of Niyati's VPC. And what is that? We'll go to VPC.
192.168.24. Yeah.
This one, right? Okay, so let's do this, and I'll put it here. This, and let's say allow SSH from Mumbai VPC. Review and launch. So there's no key pair yet, so let's create it. I'll say nv key, download key pair, and launch an instance. Okay,
In
so
this case, only Niyati will be able to
SSH.
log in SSH to this North Virginia, right? Even North Virginia, like even if I want to connect in North Virginia VPC, I will not be able to connect because we haven't set that rule, right? We have
yeah, it's
only,
correct.
yeah.
So basically, any EC2 instance running in Niyati's VPC will be able to
Mhm.
connect to this instance, but no one other than that can connect. But I don't have the private key, so unfortunately, we won't be able to. I mean, I at least from my
Uh,
machine, I won't be able to do that. Or Niyati, if you
should
can
I
paste
attach
that.
it over here?
In Skype, yeah, that would be good if you can attach it.
Yeah, let me just try.
Okay.
Web server. 1 second. Yeah, yeah, I just attached it over here.
Um,
We need to. Uh,
it has not yet arrived.
oh, sorry, I didn't press the send button. Yeah.
Okay, so I have it now. So accept. So let's. I'll.
Mumbai VPC, something like that.
Yeah, I mean, let's just short it. So I am in. Let me move to the downloads directory, and this is where we have the private key. So if you see, the VPC pairing connection is active now, and if I try to, let's connect to first Niyati's EC2 instance, and then from there we'll try to reach out to the EC2 instance which is running in North Virginia. SSH-I niyati.pem EC2-user at, what is the IP address? Okay, we'll copy it, and then we'll copy the public IPv4 address. Okay, I think security group is not letting me connect, so we can adjust that. Okay,
It's
so this
not
is the
letting. Yeah, even me, for me, it is not letting now. I
yeah,
don't
I
know
think
this.
your public IPv4 address might have changed.
Okay.
So let me do my IP. So this is my IP, and I should be able to connect now. Let's see. Okay, so we are in.
Yeah. Right.
And now let's try to do a telnet first, because we don't have the private key yet. So I mean, we can't connect, at least on this machine. I don't have the private key for that EC2 instance which is running in North Virginia. So we can quickly test the connectivity at least using telnet. So this is the public IPv4 address, and if I try to,
Private, right? Sorry, Shubham. Public, we didn't enable.
yeah, so yes, so this is private only, right? So we copied the private one,
Right.
private IPv4 address copied. There's no public IPv4 attached. So we'll try to connect. Uh, we'll try to test the connectivity if we are able to connect on port 22. So port 22 is the port for SSH. So as of now, you will see that we are not able to connect. Ah, shit, telnet is not installed. Okay, let's install it. So yum install telnet-y. Okay, telnet has been installed. So let's try to do it again. Okay, so let's copy this. So you will see that even though the VPC peering connection is active, but we are still not able to connect. And why is that? Because just setting up the VPC peering connection is not sufficient. We have to, we have to adjust the route tables on both the ends, and then we have to tell them that if you want to send anything to this CIDR block, send it via the peering connection. So let's see how to do that. Currently we are in Asia Pacific, Mumbai, and let's navigate to VPC section. And Then we'll go to Niyati's VPC, and then we'll go to route tables, and where is,
Yeah, the dev public route one.
okay, so
Dev
this one,
NVC.
right?
Yeah,
Okay,
yeah,
good.
this one.
So what we are going to do here is we'll edit this and we'll say add a route, and we'll say anything we want to send it to this network 172.17.0.0/16. Any network packet destined for this CIDR block should be sent to the peering connection, and we'll say this peering connection. So anything we want to send to this network, we'll send it via the peering connection. We'll
Yeah.
save it, and the same we have to do it for the North Virginia region. So we'll go to VPC, and then we'll navigate to route tables, and then we'll now navigate to this route table, and here we'll add a route. We'll say that anything we want to send to this network 192.168.24.0. What was it?
Yeah, 24.0/24.
Okay, good. So 24.0/24. This will go via the VPC peering connection, and this is the peering connection, and we'll save it. Now let's try to do the same thing again. So see, we are able to connect to this server on port 22,
Right.
and let's try to uh, upload the key pair for 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 that server. What is the key pair name? NV key. Okay, so let's upload it. SFTP hyphen I niyati dot.
No, NV key, right? We.
Yeah, but we have to connect to.
Oh, okay,
We can't
okay.
directly connect to NV EC2 instance, right? Because it's in private
Oh, okay,
subnet.
okay.
So we'll first connect to your EC2 instance, and then we'll upload it there, and from there we will use it. So
Okay.
yeah.
Shubham, I had one doubt over here. When you
Okay.
were editing the route tables for peering connections,
Mhm.
near these route tables was associated with the public route tables, right?
Yes, correct.
And this one was private, the North Virginia one.
Yeah, it doesn't really matter because uh, it doesn't really matter. It was just that, for simplicity's sake, I didn't create a new route table. So it
Uh,
doesn't matter whether so that route which we have simply says that anything we want to send it out to the internet should be sent via the internet gateway, and anything we want to send it to anything we want to send it to the CIDR block of
Hmm.
NVVPC should be sent via the peering connection. So
Okay.
VPC router basically would see these route table entries and accordingly basically route it.
Okay. So it doesn't matter whether it is associated with a private or the public. You can associate it with anything for
Yes,
peering
correct.
connection. Yeah.
Yes,
Okay.
correct.
so
So
that name like we gave it as public route table, but then it does the same work, right, Shubham?
um,
It
it
is
is a
just this.
public route table, right? It's a public route table. Uh, what I'm trying to say is, see, this is the subnet in which this your EC2 instance is running,
Right,
and
right, right.
if we go to the route tables, so this is the route,
Okay,
and
it
if
is
we see the
attached to
routes,
that test.
yeah. So what does it say? This route table. It says that anything we want to send to the internet would go to the internet gateway. Anything we want to send to this specific network should be sent via the peering connection.
Right.
So this is clear, right? I mean, there's no confusion in it.
Correct. Whatever
And
rules you mention in that particular table, it will follow that.
Yeah.
It is
So
irrespective of a public or a private one.
Yeah, correct. Yes.
That is what we specify for our own convenience.
Yes, correct.
Okay.
Yes. So
Okay.
now we
So
are,
can we
yeah,
have
yes.
more than one route table for a VPC, like uh, for a subnet?
No, a subnet can only be attached to one route table, but one route
Okay.
table can be attached to multiple subnets.
Multiple subnets. Okay. Okay.
Okay, so let's try to upload this.
Shubham, can you repeat? One subnet can be attached to one route table.
See, basically, uh, a subnet can be attached to only one route table. So it's not like we have one subnet and it is associated with multiple route tables. So that is not possible. But a single route table can be attached to or us can be associated with multiple subnets.
Okay.
Got it or no?
Yes, yes.
Okay, good. So I am connected to Niyati's EC2 instance, and now we'll try to upload the key, private key. Put nv key.pem. So let's do that. Put nv key.pem. Okay, it has been uploaded. Good. And now let's try to connect to Niyati server, and we'll see we have the private key now, and now we can connect to the instance running in North Virginia region. So I'll copy this, and so for security reasons we have to change the permissions for this private key because Linux detects it automatically, and if any other user other than the owner of the key has any permissions, it won't let you use that key. So I will change the permissions now. Chmod 400. I'll show you what the error you will get if you keep these permissions. So ssh-i nvkey.pem ec2 hyphen user at the IP address of the instance running in North Virginia region. If you try to connect, we'll get this error that it is required that your private key files are not accessible by others. This private key will be ignored. Bad permissions. So let's fix the permissions. We'll give the owner read access and no other user has
Any
read
other
access to.
access? Mhm.
Yeah, correct. So here we can see only EC2 hyphen user has read access to this private key. Now we will be able to connect.
This is specific only to Linux, right?
Yes, correct. So that is why we don't see this error in our Windows system. Okay, so now we are connected to that EC2 instance running in North Virginia region, and it's in a private subnet, and this VPC has no internet connectivity, so nothing will work here. Yum install httpd. If I try to do it, it will be stuck. Yum install httpd. It's not going to work because it will not be able to reach out to the repositories to download this package. So nothing is going to work out here. There's no internet connectivity.
So Shubham, Salman here. So will it work vice versa also? Like we would be trying it now.
Vice versa means from North Virginia EC2 instance to Mumbai EC2
Correct.
instance.
Correct.
Yes,
Correct.
yes, it's going to work out perfectly fine.
Okay.
It's just that we don't have, we can try doing that. We don't have Niyati's private key in North Virginia EC2 instance, but we
Very
can at least verify using telnet.
okay.
So let's
So we
do that.
can,
So this,
yeah, we can do SFTP, right? By putting near this PEM file in North Virginia, right?
yeah, we can do SFTP, but first we have to upload it to Niyati's EC2 instance. From there, again we have to upload it to
Correct.
North
Yeah.
Virginia. So a lot of
Same
hops are there.
steps. Yeah. Yeah.
Mhm.
Yeah, correct. So, anyways, I can't test the connectivity because Telnet is not installed. but if it would be there, we would be able to connect. Yeah. So this is quite straightforward, right? Any doubts on this VPC pairing?
So Shubham, just in a notepad, if you can, uh, provide like what we did. Like first we did
Steps.
this, then yeah, steps basically. Uh, because a bit of
Okay.
confusing. Like yeah, we uploaded, then we do SSH, then we did this. So yeah, can you
Okay,
mention in
sure.
one notepad? Yeah,
Yeah, yeah, sure. So basically, what we did was first thing is
created
created
VPC,
a created a VPC
VPC North
peering
Virginia.
connect. Yeah.
Okay.
So we created a VPC. So
Hmm.
we basically we can say we initiated a VPC peering connection, and we went to the acceptor VPC and accepted the peering connection, right? So let's say initiate VPC peering connection request. Navigate to uh, acceptor VPC and accept the peering connection request. Then what we do is adjust the route tables and adjust the route tables on both the VPC ends, and then that's pretty much it. So this is what is required. And if you want to SSH, then of course you would need a private key, and since we do not have that on the server, so we are using basically this SFTP to upload the private key. So you can, so this is the it's a sample command which you can adjust it accordingly. So this makes sense, right? Or do you want me to explain a bit more?
It's fine, Shubham. Yeah.
Yeah. So just put the SFTP that command. I
Ah,
guess.
okay, okay,
Yeah,
sure.
yeah. I
I
missed
think
that.
okay.
You can do it later, Shubham, when you will give us the assignments.
Yeah, that is also fine.
Yeah,
Yes.
yeah,
Okay,
yeah.
so let's do it. Okay, I'll for now.
Sure,
I
sure,
think
sure.
it's almost done, but
Yeah.
okay. So we are done with the VPC pairing. Now let's move on to NAT gateway. So what is an NAT
So,
gateway?
sorry,
Yes,
Shubham,
what is
one
it?
question. Yeah.
Uh-huh.
So, in case like any changes we do in the Mumbai region EC2 instances, so will it be now replicated to North Virginia? Like
Of
for
course not,
yeah,
because though there is
yeah,
a peering connection active, but what is responsible for replicating the changes? Not AWS, right? If it's something like an AWS, I
okay.
mean, if it's something like a database,
Mm-hmm.
you have a primary DB
Correct,
on
correct.
Mumbai, and then you have secondary DB on North Virginia, and then you explicitly, either set up whatever
Set the
could be
replication data
database,
guard. Yeah,
yeah, tools,
yeah,
yeah, data
okay.
guard. So then
Got
it
it.
will move the changes, but no changes will be automatically replicated. It's
Automatic.
just the connectivity from network
Correct.
perspective.
Okay. Got it. Shubham. Yeah. Thank you.
Okay, so let's see what NAT gateway is. So in the beginning, Niyati asked a very good question that what about the instances in the private subnet? So suppose we have to update the packages installed in on the instances running in private subnet, since those instances are in a private subnet and does not have internet connectivity. How do we patch uh, those instances, because this yum update would not work there, or maybe we have to install some packages, or we have to update the existing packages. How are we going to do that? So so the answer to that is NAT gateway. So so what NAT gateway is, the instances in the public subnet can send outbound traffic directly to the internet via the internet gateway. whereas the instances in the private subnet can't. We know that. So instead, the instances in the private subnet can access the internet by using a NAT gateway that resides in the public subnet. The database servers can connect to the internet for software updates using the NAT gateway, but the internet cannot establish connections to the database servers. So what does it mean? If we move to this diagram here, you will see this is a one VPC we have, in which we have only two subnets are there. One is a public subnet, one is a private subnet. In public subnet, we have three web servers here, and has all of them has an elastic IP. Elastic IP, will discuss what those are, but essentially those are public IPv4 addresses. So all these instances, web servers which are in public subnet, they have a public IPv4 address. And if you see this custom route table, which is associated with public subnet, has a route to the internet. Here we have mentioned that anything we want to send it out to the internet should be sent to the internet gateway, IGW. So here, how do we give connectivity to these database servers which are running in private subnet? So basically the secure way of giving outbound internet connectivity is via NAT gateway. So this is where NAT gateway comes into picture. So NAT gateway uh, runs in a public subnet, and what we'll do is basically anything we want to send out to the internet will send to this NAT gateway. NAT gateway on behalf of these database servers will basically make requests to those servers it is trying to reach out on the internet. It will basically uh, it will try to reach out on these servers behalf and download the packages and then basically send it back to the database servers. So basically the servers it is trying to reach out on the internet, to them it would look like as if the request is coming from the NAT gateway, and they will send the whatever the response they are sending, they will send it to the NAT gateway, and it is NAT gateway which eventually routes it back to the database servers. So basically it's just one way connection. Database servers can reach out to the internet via the NAT gateway, but any machine on the internet would not be able to establish a connection to the database servers. It's just one way connection. So database servers can reach out to the internet via the NAT gateway, but internet can't reach out to the database servers. So does it make sense?
Yeah,
Right.
Shubham.
Yeah.
Okay, so let's try to create a NAT gateway and see how we can give connectivity to instances running in the private subnet. Before that, let's quickly see what an elastic IP is. So if we see, this is Niyati's web server, and it has a public IPv4 address. Okay, and but you will see that if I stop it and start it, this public IPv4 address would change. So you can make a note of this. So currently this is the IP. This is the public IPv4 associated with Niyati's EC2 instance. If I stop it, okay, if I stop it and I start it again, we'll see that this public IPv4 address has changed. So then it's a problem. It may be a problem for you. Say for example, in your DNS servers, you might have, maybe this is a web server, and in our DNS records, we have mentioned like uh, niyati.com basically points to, we might have a type record for niyati.com, which basically is this. So basically any DNS resolutions which are happening for niyati.com, it will be resolved to this IP address. Now the problem would be that if somebody stops it and starts it again, the IP address would change, and then somebody has to update the DNS records as well, and which is not a good idea, because if it keeps changing like this, and even for DNS, first thing is who is going to keep updating that, plus this DNS resolution also gets cached, so that is another problem. So basically it's not a good idea for some use cases like serving a website. So for that cases, if you want a static public IPv4 address, then we have to use elastic IPs, and so it is currently stopping. This is called hard.
So, Shubham, you mean like we would be having a static IP in case like this public IP is dynamic and it changes, right?
Yeah. So if you want a static public IP, then you would have to provision yourself an elastic IP, and then you have to associate that elastic IP with your EC2 instance or with your web server. And then no
Got
matter if you start it or stop it, the public IP is not going to change.
okay. Got
Okay, so it has been stopped now, and we talked about the scale up or scale down. So we can test it now. So it's very easy to change the instance type. All you have to do is you have to stop the EC2 instance, and then you can go to action, and then instance setting, change instance type, and we can change it to maybe if you want to do a scale up, then we can select a bigger size from T2 micro to let's move it to T2 small, and we'll apply it, and will so now we see the instance type is T2 small, and what we can do is we can start it again. So this is a simple scale up activity. Similarly, we can also do scale down. So maybe if you have provisioned a server and then you later realize that you have over provisioned it, and we really don't need that many CPUs or that many memory. So we can plan a downtime of 5 to 10 minutes. We can stop the instance, change the instance type, and start it again. So it is very easy to scale up or scale down in a cloud environment. So that is one of the primary advantages of running infrastructure on cloud. So now we see it is T2 dot small, and if I go to the details, okay, so now we see the new public IP address is this. So public IP has changed, and maybe we don't want this to happen. We want a static IP. Then what we are going to do is we'll go to elastic IPs here, and we'll provision ourselves a elastic IP. We'll say allocate elastic IP address, and we'll simply say allocate, and then so once it is allocated, it is basically it is allocated to our AWS account, and until we explicitly release it, it is going to be associated with our AWS account. So what we are going to do is we'll say actions associate elastic IP address, and we want to associate it with our web server, and I'll say associate. So it has been associated. Now if we go to instances and if I refresh it, then we see that this is a static IP. If I try to do a stop, and if I do a start also, this public IP is not going to change. one thing that we have to be careful with regards to elastic IP is that, see, we should know that elastic IPs or public IPs are rare. It's not in abundance. Even AWS doesn't own a lot of public IPs. So they have some IPs which they can allocate or give it to customers, but even they do not have, a lot of IP addresses. So I think you can request 5 elastic IPs from AWS, and you have to be careful if you simply allocate yourself an elastic IP but you do not associate it with a running EC2 instance, then Amazon is going to charge you for that. I- so you are not going to be charged for elastic IP as long as it is associated with a running EC2 instance. If it is not associated with any running EC2 instance, then you are going to get charged for these elastic IPs. Okay, so we have to keep in mind, in case we have provisioned an elastic IP and we have attached it to EC2 instance, then while terminating the EC2 instances, we also have to release the elastic IP. Otherwise, we are going to get charged, and these elastic IPs are not as part of free tier. So, so this is one thing.
Actually. So Shubham, we need not again need to update anything in the route table for this.
For what? For this for using elastic IPs?
Correct, yeah, elastic IP.
No, no, we don't have to do that. So
Okay.
we are currently having T2 dot small. So we are again doing a scale down because the T2 dot small is chargeable. So we'll switch back to T2 dot micro. So what we are doing here is essentially we are doing a scale down from T2 small to T2 micro. So we are doing a T2 micro and we'll apply it. And if we see this, even when this EC2 instance is in stopped state, the IP address is the same. And even if I mean, of course, if I start it, the IP address would be remain the same. So this is what elastic IPs are.
So
Got it.
only one I mean, only one elastic IP per VPC can be allocated, right? The
No,
same
no, I
elastic IP
think
can.
it doesn't matter when you provision yourself elastic IPs, it is not tied to any specific VPC. So you can provision yourself up to 5 elastic IPs, and it's up to you whether you want to associate all those 5 IPs with instances running in the same VPC, or instances running in n number of VPCs. Got it?
So, Shubham, if we have more than 5 instances of for which we require the public IP, those are in the public subnets. Okay. So, what in that case, because we are bound to only 5 elastic IPs?
See, normally most of the limits that you would see in AWS, those are soft limits, and you can raise a service request to AWS and then request them to increase it. Of course, Elastic IP is not something they would immediately increase it because even they have a finite supply of it. But if you explain them the architecture and the use case that you need to have more than 5 Elastic IPs, they would be able to change it for you. But the thing is, it is very unlikely that you will need more than 5 Elastic IPs. Why? Because these normally if you want these elastic IPs for web servers, right, then you don't need it because you can deploy a application load balancer in front of them, and you can have a lot of web servers behind it, and all those web servers doesn't need to have a public IP. So basically, whosoever is trying to access the web application or the website, it will try to connect to basically the load balancer URL, and the load balancer internally will basically distribute the incoming traffic to all those web servers behind, or basically all those web servers supporting that web application. So all those web servers doesn't necessarily need a public IP. So we can deploy a load balancer in front of that. So I mean, in very rare cases, you would find a use case where you actually need more than 5 Elastic IPs.
Right. Correct. Correct. Right.
Okay.
Got it.
So,
Yeah.
so here you can see if you go to limit section, here we can see we have these limits. If we try to see what limits are set for elastic IP, current limit is 5, and so similarly for there are other types of limits also. So most of them are soft limits, and we can reach out to AWS and basically request them to increase the quota for us. So let's do that. What I'm going to do is, for now it's fine because this elastic IP is associated with a running instance. It's fine. Now let's try to do one thing. I'll show you one thing which I think we haven't discussed, which is uh, regarding user data. What user data is? Okay, let's finish NAT gateway first. So I'll create a instance in the private subnet. I'll go to launch instance, Amazon Linux AMI, T2 micro, and we'll say uh, dev in VPC.
Right.
We'll, yeah, so we'll use this private sub one. No need to assign a public IPv4 address because it's a private EC2 instance, and we'll say add storage. This is fine. Let's give one name. It's a private. It's a DB server. And configure security group. Okay, so anything is fine because anyways this is not reachable from the internet, so we can keep it wide open. There is no issue with that. And we'll say review and launch, and let's say near the web. So we are going to use the same private key for this one. So we'll wait until this is launched, and then
So did you download that key, Shubham?
no, I am using the same key which we have
Oh,
already
okay,
used,
okay.
right?
Oh, okay, 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 okay.
Okay, so let's try to connect to your instance first, and then from there, where are we? It's a big downloads, ssh-i, and then niyati. What is that? Niyati.pem ec2-user at. Okay, I'm already inside, but we don't have your private key here, so let's do that again. See, the syntax for SFTP and SSH is same. Just replace SSH with SFTP. So I'll say SFTP, and I'm connected here. And to upload a file, we'll say put. To download a file, we'll say get. So I'll say put near the .pem. That's it. So it has been uploaded. I'll exit out of it. Now again, I'll connect via SSH, and now that key would be in the home directory of ec2-user. I'll change the permissions now. Chmod 400 niyati.pem. So the permissions are corrected now. Now let's try to connect to the private instance to the DB server. Uh, instance summary. Okay, so I'll copy this private IP, and what is this? Why?
Is it because it says still initializing, Shubham? The
Is it initializing? Because I see it's running, right?
Oh, okay, 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 okay.
Okay, so
Okay,
let's
okay.
see why we are getting this. Shouldn't be the case. I'm actually surprised. Hmm. So could be that we have not used the right key for that. That's the only explanation I have.
So like earlier, what happened is when we were practicing Shubham,
Uh-huh.
we while creating, I think while creating the VPCs.
Oh, so did you create two?
Yeah,
Ah,
there were two. Should I give you the other one? I have it with me.
yeah, that would be good. If you have it, we don't have to
Double
terminate it.
security.
Yeah. No, no. Actually, we created twice. So yeah, once we terminated and then we created another one. So yeah, that
Sure.
Okay, so fine, good.
I just gave you.
Okay, so let's upload it. Then I'll exit out of it and TP, and we'll say put nearty hyphen web.gem. It has been uploaded, and then let's again connect to this benchmod 400. Yes, so we are inside the DB server, and here if we try to do yum install or yum update, it's not going to work because it does not have internet connectivity. So let's see how we can create an NAT gateway. Now we'll go to VPC.
Oh yeah. Can we put our call on mute? Only. Yeah.
Yeah, this is
Yeah.
much
Now we are
better.
clear. Yeah.
Okay, good. So here if we see, so we managed to connect to the DB server, which is in private subnet, and as expected, we are not able to perform any yum update or yum install because it does not have internet connectivity. So what we are going to do is we'll try to give internet connectivity to this DB server via the NAT gateway. So NAT gateway gives only outbound internet access. So DB servers would be able to reach out to the internet for any software updates, but no machine on the internet would be able to connect to DB servers. So let's see how we can do it. So we'll go to this VPC section, and here what we are going to do is,
It was yeah, over here it is the
yeah,
NAT
it's
gateway.
here, NAT gateways. So we'll say create NAT gateway, and then we'll say NAT gateway, NAT gateway for dev VPC, and we'll select the subnet. So it has to be a public subnet. This we have to remember. So any public subnet is fine. So where is the public subnet? Is this the correct one, Niyati?
Right, 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 right. That is the one.
Okay, so we have given a name to the NAT gateway, and we have to remember the NAT gateway has to be deployed in a public subnet, because NAT gateway should have internet connectivity. Because if NAT gateway itself does not have internet connectivity, then how it is supposed to reach out to the internet on DB server's behalf? So we have selected a public subnet, and then we have to remember that NAT gateway requires an elastic IP. So what we are going to do is we'll allocate an elastic IP, and then it is done. We'll say create NAT gateway. So NAT gateway has been created. The state we see is pending. Once it is
Shubham, what was that connectivity type, public, private? What about this?
Uh, see, normally it would be public only, but in case you have an on-prem scenario, maybe we'll discuss some other time in what cases you would require a NAT gateway of type private. But for now, we'll in this
Okay,
use case, it would be public. Okay,
sure.
so it is currently in state pending. We'll say in some time I think it would be changed to deployed. So let's see.
So Shubham, this public no, it is private IP address. I thought we are assigning that public IP address to that instance also, and over here also in NAT gateway. Mm,
See,
somewhere
NAT
we are
gateway, I mean, once it is deployed, you would see one elastic IP address also. Of course, this is going to have a private IP address as well, because ultimately NAT gateway is something which is residing in our VPC. So anything
right.
we deploy in a VPC would consume one IP address, right?
Right, right. No, so this elastic IP address would be different from the one which we gave to the EC2 instance, right?
Yes, correct.
Okay.
So if we
Yeah.
see, as of now, we'll have two elastic IPs in our account. So one would be associated with the web server. This is the
Okay.
EC2 instance, and the other is associated with NAT gateway. Okay.
Right. Right.
So now we see NAT gateway is available. So now there's only one thing left, and what is that? We have to adjust the route table. Okay. So we'll go to our VPCs. We'll go to the subnets, and let's expand. So this is what is the correct private
Yep.
subnet for this one?
Dev. Yeah. Private subnet one. Yeah, or
Okay, I think route tables. Okay, we'll go to route tables, and so I think you have not created a private route
yeah,
table,
yeah.
right?
We haven't created. Yeah.
Okay,
Only
so that
public.
means currently these private subnets are associated with the main route table, right?
Right, right.
So what we'll do is we'll adjust the main route table itself. There's no problem with that. So we'll see what is the main route table associated with our dev and VPC. Okay. So let's sort it by this. And so this is the main route table. Okay. For your VPC. And
Right.
this is the route table which is associated with the private subnets. Uh, So if we see here, if we scroll it down, subnets without explicit associations, the following subnets have not been explicitly associated with any route tables and are therefore associated with the main route table. So we'll edit the main route table itself. What we are going to do is we'll say edit routes. We'll add a route. We'll say anything we want to send it out to the internet. We'll send it to the NAT gateway. So NAT gateway. This is the NAT gateway, and we'll save the changes. And now let's see. So first, I think the connection, we lost the connection. So first we'll connect to Niyati's public server, then we'll connect to the DB server. So now, okay, same
The
issue.
other one. The other one. Web one. Web.
Web one,
Yeah.
right? Okay. Okay, so now we are in. So currently we are in the DB server, which is in a private subnet. Now we should have internet access. Let's try to install telnet here. Yum install telnet -y, and we can see that we are able to download packages from the internet.
Right.
Even though it's in a private subnet, it doesn't have a public IPv4 address, but still the internet connectivity is working. So this is what NAT gateways are. So any doubts on this?
You could just summarize the high level steps what you did.
So high level step is it's quite straightforward for deploying a NAT gateway. We go to VPC section, then we navigate to NAT gateways. There is an option to create NAT gateway. We say create NAT gateway. We'll select a NAT gateway of type public. NAT gateway has to be deployed into a public subnet that we have to remember. So we have to select the appropriate subnet, and that subnet has to be public. So we have selected one of the public subnets, and then NAT gateway needs a elastic IP. If you have already created an elastic IP, you can associate that elastic IP with this NAT gateway, or there is a button there, allocate elastic IP. We click that. So AWS provisions on our behalf and associated with the NAT gateway. So then we go ahead and create it. So once the NAT gateway is available, then we have to see which route tables are associated with private subnet. Then we go to that route table and we add an entry wherein we say that anything we want to send out to the internet, it has to be sent to the NAT gateway. And this is how the connectivity happens. So basically these DB servers would basically make a request to the NAT gateway. NAT gateway on DB servers behalf would reach out to those repositories hosted on the internet. It will try to download those packages and then basically route it back to the original instance who made the request. To the servers hosted on the internet, it would look like as if the request was made by the NAT gateway itself. It will basically send the response back to the NAT gateway, which in turn will send it back to the DB servers. The advantage is that it's just a one-way internet connection. DB servers can reach out to the internet, but internet can't reach out to the DB
NAT
servers. Yeah, they can reach out to the NAT gateway, but not to the backend instances.
Okay.
Okay, so this is what NAT gateways are. So do you guys need a 5 minutes break or shall we continue?
Oh,
We can continue, I think,
we
Shubham.
can continue. I think like
Okay,
topics are
so
left, right?
yeah, there's a lot of topics left, but okay, so NAT gateway have terminated. Elastic IPs also will release it.
So while practicing, we should also force
Do a
stop this
cleanup.
elastic cleanup,
Yeah,
right? Remove elastic IP, remove gateway, right?
Yes, yes, correct. So we should, delete all the resources that we have created. So we'll do the same. So for this one, I'll first disassociate the elastic IP. So it has been disassociated, and now I will release it. So this has been released. So now only one public IP is left. This is associated with the NAT gateway, and uh, and let's try to release it. I think we'll get an error. Okay, it has been released, so it's fine. So elastic IPs have been released, NAT gateway has been deleted, and so we have
I think we have an two EC2 instances running.
yeah, for now it's fine. We'll leave it. Once this class is over, I'll terminate them. Okay, why not terminate it now? I'll show you one more thing because we don't require these anymore. So it's just a matter of a couple of clicks. So these have been deleted. Now let's continue with the next topic, which is user data. So what is user data? So when we launch an EC2 instance, we have the option of passing user data to the instance, which can be used to perform common automated tasks and even scripts after the instance starts. And user data can be used to run Linux commands or shell scripts, or in case of a Windows instance, it can be used to execute a batch script or a PowerShell script. So if we want to do some kind of automated configuration, say for example, as of now, if you see, while we were launching the EC2 instance in our first class, we first launched the instance, then we connected to the EC2 instance via SSH. Then what we did, we installed Apache Web Server. Then we started the Apache Web Server, and then so these are some of the tasks we did. So if we don't want to do it manually, if then we have this option where we can prepare a script. That script we can pass as a user data once the instance boots up. Basically, once the instance has started, AWS automatically runs those set of commands on our behalf, and those will be executed. So any kind of automated configurations that you want to do, that can be done using user data. Could be like, maybe assume a scenario wherein there is this auto scaling group. This auto scaling group automatically launches web servers as the load on the web application exceeds. So maybe this we have this auto scaling group, and then there are certain there are certain monitoring that you can do, and you can say that if the CPU utilization is going above 80%, launch one more EC2 instance. So auto scaling group on our behalf will automatically spin up an EC2 instance. So for such automatic spin up of EC2 instance, nobody would actually be logging in and doing all those configuration tasks. So in those specific scenarios, it is very good to have something like user data, where we can specify that once when auto scaling group launches an EC2 instance, after that this script that we have provided under user data, that will be executed. And what it will do, it will simply install a web server. It will start the web server, and probably it will download the latest code from S3 bucket. So that also we can do. So once the server has been installed and it has been started, it will download the latest code from an S3 bucket and deploy it onto the web server, and then it is ready to be a part of the web application. And soon it will be ready, and the load balancer, which is basically distributing traffic, it will start distributing to the newly added instance as well. So we'll see that in action, then it will make more sense. So let's try to launch an EC2 instance, and we'll see where we have that option where we can specify a script. So we'll say launch instance. We'll select Amazon Linux 2 AMI, select, and then we'll stick to T2 micro, and then we'll select our VPC dev and VPC. We'll select one of the public subnets. So public subnet 2, it's fine. We'll enable IPv4 address, and then if we scroll it down, here we see this section called user data. So here we can specify a shell script. So what I'm going to do is I will say bin bash. I'll say yum install httpd -y service httpd start. So if we do this now, then we can say add storage. Root volume is fine, and we'll say configure security group. I'll use an existing security group. Okay, there's no existing security group. I don't know. I mean, what
Yeah,
rules are there? Which
the
one?
one with,
Sorry.
yeah, this one.
Okay. So HTTP and SSH. I don't know whether it's my IP or not, but anyways, we don't have to SSH into it. So we'll use this security group. We'll say review and launch. We'll launch, and let's say okay, near the web. We'll select this one, and I'll say I have the private key, and I'll launch it. So we'll wait until this is launched, and after some time we'll try to access it on a web browser, and hopefully we should see some default web page because we are installing Apache web server through a user data script. So if all goes well, we should be able to connect to this web server on port 80. So let's see. Okay, so it's up and running, and we'll select this. I'll copy the IPv4 address, and let's see if we are able to connect to it. Not yet. Maybe that is in progress. So we'll try maybe in a minute or so. Okay, so here we can see. So
Right.
this is, yeah, so this is what user data section is, wherein we can pass some shell script, or in case of Windows, we
So,
can yes.
yeah, the default user for this, suppose if we are running any command, what will be the default user? Will it be root or like any defined user?
It will be root. So
Okay.
these commands will be executed as root.
And if you want to run specific command with other users, suppose for as an Oracle instance, I want to check if the databases are running. So I do sudo su Oracle, then I do srbctl. I mean the status of databases. So is that possible?
Yeah, it depends upon I mean how you write the script. I think it should be possible to switch to some other user and execute certain commands.
Okay.
I mean, normally in the AWS console, there's no option where you can specify a custom user, but if it can be defined in the shell script itself, then it's possible. Even I am not a shell script expert, but
Okay.
Okay,
so we'll
and
see.
one question, like as you say, we need to do shell scripting in the user data part, right? So we can specify some output and send it to our email ID. Is that possible? Like what we generally do in shell scripting.
Yeah, of course. I mean, it depends upon how things are set up. Say, for example, if you have a internal mail server or
Mhm.
or something like that, so we can it can be done. Yes, of course.
Okay.
Shubham, in that case, do we have some things like SMTP mail for that you need to be activated, right? So is that by default there in the server, or we'll have to load it?
I know we have to do it ourselves. So these are just regular. I mean, these are Linux. It requires a Linux expertise, and this is a normal thing that you would do even in a on-prem environment. So it's no way different than here in AWS, because what we are doing at OS level, it remains the same even in AWS.
So every time this instance you said, every time this instance starts, this will do the steps which is performed.
No, it is only performed one time while the instance is being launched the first time, and
Right.
if we stop it and start it again, the script would not be executed only one time while the instance is being launched for the first time.
Okay. Apart from that, when we just stop and start it, say during the night time we stop and during the day we again start it, it will not do it again, right?
Yes, it will not do it again. Yes, correct.
So
Okay.
is there any way we can do that, or is it not possible at all?
I think
There,
Lambda.
yeah, Lambda can be used, and there is something called as Systems Manager. Through Systems Manager, it is possible to do that. We'll see
Okay.
Systems Manager later on. So that can do a lot of things for us. So it's quite good. We'll see that later on.
Sure,
For
sure.
now, just in case if we want to troubleshoot, say for example, the script didn't work out as expected. So where can we see the logs? We'll see that. So I'll try to connect to this server now. So this is the public IP for this EC2 instance. Um, and
Yeah,
in
we are
case
using
if I,
Niyati Web. Yeah.
okay. Here SSH I have to adjust. So I'll go to security groups,
So,
inbound
Shubham,
rules.
yeah, why are these inbound rules getting changed every time? Like, because once we set as my IP, right? Then, like, why is it getting changed every time?
I mean, this is your IP, it's not mine, right? Because this is what you have created it, and normally we do not get a static IP for us when we request the internet from an ISP. If we are some enterprise customer, if we have requested for a static IP, then it would not change. Typically, in a
Okay,
corporate environment, you would see a static IP, but at least not for
okay,
us. It's just a good
right,
practice to restrict it, but normally in a enterprise environment, you would already have a static IP and it would not change.
right.
So let's do it. I'll say my IP and I'll save it. And now we should be able to connect here. So okay, I'm inside. And now if we want to check where we can find the logs for that user data script, we'll go to var log directory. And here we can see cloud init output.log. So here we can see the output of that shell script. So I think so
Yeah,
basically,
right.
yeah, running transaction check package httpd, and this is basically dependencies have been resolved. Installing httpd, in transaction summary, install one package, downloading packages, installing, verifying, installed, dependencies also installed, and it has been complete. And here this was service httpd start, and basically this is also started. So this is where we can see the logs of the user data script. Under var log directory, there you'll find this log file cloud init output.log. So here we can see in case the user data script is not working as expected, you can check the logs. The important thing to note is we should not keep something, that script should not wait for any user interaction. Say for example, if I say uh, yum installed maybe what nginx, no package available. Okay, yum install nano. I can't think of a package, but normally if you see, if we say yum update, then it will basically give you any packages which are available for update, and then it will say yes or no. So that is why we have to, I mean, you have to remember all those things, that the script should not wait for any user interaction, otherwise it will never be executed successfully. So a bit of those things we have to remember while creating the user data script.
So, Shubham, is there any way we can check the logs from UI?
No, not from UI. We can't check it, so it has to be
Okay.
checked at OS level only.
So
I mean,
even if
what?
that user,
Mhm.
Yeah, even if that user data script fails, we our EC2 instance will get launched, right, Shubham, in any ways.
Yeah, it will be launched in anyways. Yes, correct. And
Okay.
so this is a simple batch script for Windows. So in case we are launching a Windows server, then we can provide a batch script inside this script tags. And if we are executing a PowerShell script, then the script would be replaced with PowerShell. There will be a instead of script there will be a PowerShell, and then there will be a closing tag for PowerShell, and in between there will be PowerShell commands in case of a Windows box. And now let's see what instance metadata URLs are. So there are some URLs which we can query to find details about the instance. So uh, let's say maybe I'm a Linux admin. I do not have access to AWS environment, but I want to pull some data about this EC2 instance in which I'm currently logged in. So how we can do it? There is a instance metadata URL which we can query, and so let's see how to do that. So there is a HTTP client called curl. Using curl, we can try to connect to this instance metadata URL, and the URL is like this: 169.254.169.254 slash latest slash meta hyphen data. Then you can see we can get all these information without actually having to log into AWS Management Console. If I want to see from which AMI ID this instance was launched, I can do this. So this is the AMI ID which was used to launch this EC2 instance. If I want to see the public IP attached to this EC2 instance, I can basically check like this. So this is the public IPv4 for this EC2 instance. We can also see what security groups are attached. So this is the security group currently attached to this EC2 instance. So all sort of stuff we can do from this. We can also get the instance ID of this EC2 instance, and it's up to you how you want to use it. Could be that even the user data script, say for example it's a web server and it has a public IPv4 address. So could be that uh, once the instance has been started, this user data script might be querying this instance metadata URL to retrieve the public IPv4 address, and then it may make some API calls to Route 53. So Route 53 is a basically a DNS service offered by AWS, and it can update the DNS records with the public IPv4 address of the web server. So it's just one scenario. So it's up to you how you want to use this instance metadata
This
URL.
169 254 169 254, this is common for everyone, right?
Yes, it's common. So basically it depends upon in which instance you execute this. You would see data specific to that EC2 instance.
Okay.
Okay, so and we can also if we want to see what user data script uh, was passed on while launching this EC2 instance, that also we can get it. We can simply replace the metadata with user data. Let's try to do that. I think it's user hyphen data. Yes. So if we want to see what user data script was passed while launching the instance, we can query this URL, and here we can see this is what we have passed. So any questions on user data or instance metadata URL?
So Shubham, for say specific user, like so it will it is but obvious like we would need that user first to be available at EC2 level, right? Any of
Yes,
user
correct.
say.
Of course.
Yeah.
Yes.
Okay. So for that specific user, say example, we schedule some job running from Oracle ID. So that
Uh-huh.
Oracle ID for that code would be mentioned in the console itself, like how it would be then.
See, normally, I mean, while we are launching the EC2 instance for the first time, I don't know why,
Mhm.
how, I mean, why would you try to start the Oracle database? Because normally it would be just a blank server operating system onto which nothing is installed, right?
Correct. Yeah.
So, I mean, doing all this fancy stuff like, starting some enterprise level application is not something for which user data script is intended. User data script is intended for some simple task like updating the packages so that maybe the AMI may not have the latest packages installed. So once it is launched, the it it should automatically patch whatever security updates are available, or installing or specifically starting some services. But maybe for an Oracle database, um, there are ways of doing through systems manager. We'll see how we can do that. So systems manager has uh, lot of
Got it.
capabilities. There is something called as an SSM agent, which is installed on the server, and using that, there can be lot of things that we can do.
Sure,
So,
Shubham. Okay, yeah. Thank you.
okay. Um, let's talk about EBS now. What EBS are? So EBS stands for Elastic Block Storage, and Amazon EBS allows you to create storage volumes and attach them to Amazon EC2 instances. Once attached, you can create a file system on top of these volumes and run a database or use them in any other way you would use a block storage. Amazon EBS volumes are placed in a specific availability zones where they're automatically replicated to protect you from the failure of a single component. All EBS volumes offer durable snapshot capabilities and are designed for 99.999% availability. So what does it means? This means that, see, elastic block storage is basically, you can think of them as virtual hard drives which you can use with your EC2 instances. So if you want, say for example, we already know one root volume. So root volume is what? So root volume is where our operating system is installed. But typically for any application uh, that we want to run on an EC2 instance, uh, it requires dedicated file systems. File systems maybe where your data files are there. Could be, in Oracle also we have table spaces, then we have data files, and then we have what, online redo log files. Then we may need a separate file system for ORARC, for offline redo log files. So all these would require what, separate file systems. And how to get
Mm.
file systems for an EC2 instance? By first creating an EBS volumes, then attaching it to those EC2 instances.
These are basically
Once,
mount points, like whatever we have usually in a server.
yes, correct. So when we do df-h, we see several file systems, right,
Correct.
mounted onto some mount points.
Right.
So
Yeah,
if we,
Shubham,
yeah,
can you hear me?
yes, I can hear you.
Actually, my Bluetooth got disconnected. So, you just started EBS, or because I
Yes, yes,
missed
we just
one?
started EBS. You want me to repeat it?
Yeah, yeah. Please repeat because I just reconnected. Yeah.
Okay, sure, no problem. So basically, what EBS are? EBS stands for Elastic Block Storage. This is a block level storage, and you can think of these EBS volumes as virtual hard drives, which you can attach to your EC2 instances. So we are already aware of the root volumes. So while launching the EC2 instance, we see one root volume. So root volumes are where our operating system is installed. But typically for any enterprise application, could be an application or a database, we would require additional file systems, right? other than the root volume. So in case of an Oracle database, we might need several file systems where where we keep the data files, right? And we might need some file system for the online redo log files. We might need a separate file system for offline redo log files. So in any application or database, if we execute df-h, we see several file systems, right? Every file system has some specific size, and we can also see how much percentage of the space has been utilized, where it has been mounted. So basically, to get any file system on the EC2 instance, first we have to create EBS volumes. Then we have to attach those EBS volumes to those EC2 instances. Then we can format it. We can format those EBS volumes with the file system of our choice. So there are several file systems available, right? In case of Windows, we have NTFS or FAT32. For Linux, we have ext3, ext4, or XFS. So these are separate file systems formats. So basically, EBS volumes are virtual hard drives for our EC2 instances. And if we want any file system other than the root file system, we would have to create EBS volumes, attach it to our EC2 instance, then we'll format it, and then we'll mount it. So we'll quickly try to do it and see how we
So
can
is
create an
it
EBS volume.
is it chargeable and
Of course, it is chargeable. Yes, in cloud, pretty much everything is chargeable. So
okay?
EC2 instances are charged. Let's talk about EC2 pricing a bit. So essentially, at a very high level, there are three pricing models for EC2. One is on demand. So there is no commitment, and you are billed per second for EC2 instances. And the minimum period, of course, should be 1 minute. And then after 1 minute, you are charged per second. So basically, for how long your EC2 instance is up and running, you're charged based on that. So there are three pricing models for EC2. One is on demand, the other is reserved, the third is spot instances. So on demand billing model is suitable when basically you're testing out or you're building some POC environment. But once you have figured out that how much capacity you need, typically the best way of going with it is you commit. Basically, you go with reserved instances. You say that I want these instances. Say for example, once you have figured out that to support your web application on normal days, you need three EC2 instances of type maybe T2.xlarge. So this is three EC2 instances of type T2.xlarge is sufficient to basically handle your web application in most cases. Only in specific scenario where you are getting more than expected load, then you may need additional EC2 instances, but at bare minimum, you always need at least three instances of type T2.xlarge. Then there's no point in running those EC2 instances in on-demand model, because if you can commit that, if you can say that I am going to use three instances of type this for a year or for 3 years, you can get significant discount on the pricing. You may get up to 70% also as compared to on-demand pricing. So, so the other is reserved instances. So once you have figured out that this is the bare minimum capacity you need, you basically, you sign up a contract. So these reserved instances you can get for 1 year term or for 3 years term. It depends upon you. For the longer the commitment, the more the discount. So you can get up to 70% discount. The bad part is that you have already paid it, and even if you stop it, you may not save a lot of cost. And then spot instances, what spot instances are basically, see, Amazon being a public cloud provider, they have to they have to keep a lot of capacity, because if they run out of compute or if they run out of storage, then it would not be a cloud. Because I mean, an idle cloud should be scalable. So the I mean, AWS doesn't really know which customer might come up with what kind of demand. So they have a lot of capacity in their data centers. So a lot of times, they might not be not a lot of customers are requesting for that capacity, and they might have lot of idle compute capacity. So you can bid for those idle uh, capacity, and you can run EC2 instances at up to 90% discount. But the catch here is that they may reclaim that compute whenever they need it. If customers are willing to pay on demand pricing for those EC2 instances, they are going to take away your spot instances. So spot instances are idle for some kind of a processing where even if it stops abruptly, it doesn't it doesn't create much of a problem. So for those kind of use cases, spot instances are idle. So this is EC2 pricing model. And there are other two pricing models also. I mean, one is savings plan, and even in reserved instances, there are two, three types like scheduled reserved instances, convertible, and standard reserved instances. So those I'll give you one link. So those are just some theory around it. So, but at at a high level, when it comes to EC2 pricing, the three pricing models: one on demand, reserved instances, and spot instances. Maybe we can do a lab later on spot instances, that how to see what is the current bid price for any EC2 instance, and then we can basically get an EC2 instance at a much higher discount. But the catch is they may take it anytime they feel like, whenever customers are willing to pay the normal price for that EC2 instance. Similarly, for EBS also, they charge you per GB per month. So they may charge you, this is just an example, they may charge you, say for example, 50 cents per GB per month. Okay. So based on that, how much big EBS volume you have provisioned, based on that, you are going to get charged by AWS. So, any questions on either EC2 billing or EBS volumes?
So the one you say on demand,
Mhm.
like the bidding happens, right? So once the like I'm taking it on a higher bid, so you will be informed, right? Like the someone is taking it in on a
Uh,
higher bid.
no, actually, here I think you mean to say spot instances, not on
Yeah,
demand,
sorry,
right?
sorry, 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 sorry. A spot instance, spot instance.
Okay, so if for spot instances, they're going to they're going to tell you that this is the current price. Okay, this is
Mhm.
the current bid price, and as long as you are ready to pay the current bid price or a price higher than the current bid price, you can you will be given a spot instance. Say for example, the current bid price is 50 cents. If you say that I'm willing to pay 60 cents, then also they're going to charge you 50 cents only. Okay. They're
Okay.
not going to charge you 60 cents. It's not like, you said that I'm ready to pay 60 cents. So they're going to charge you 60 cents. They're going to charge you 50 cents only. But the thing is, I mean, you will be able to run your spot instance until the current bid price does not exceed the price which you have quoted. Say, for example, current bid price is 50 cents. You have quoted 60 cents. Okay. See, if that is the case, you will be given an EC2 instance. If later on, if the bid price changes from 50 cents to 70 cents, then your spot instance would be taken away because the bid price has changed from 50 cents to 70 cents. So as long as the current bid price stays lower than what you are willing to pay, I mean, you will keep running your spot instance.
So when they take away, so is it like they wipe out all the data or terminate? Like what happens actually?
See, what happens actually is it depends upon how you have launched that EC2 instance. Normally, the default behavior is that the root EBS volumes also gets terminated when your EC2 instance gets terminated. But of course, you can unselect that option. Just that the EC2 instance would be taken away and your EBS volumes would be preserved.
Reserved,
So
yeah.
the storage would be preserved.
So the idea is to get an EBS volume, right?
Yes, yes,
To
get
protect our
an
data.
EBS volume. Yeah, correct. Yes.
Okay.
So normally, I mean, you should not be much bothered about when they take away. The use case should be like that, that it shouldn't matter when AWS takes away a spot instance. Something like, which it does some processing, or and then it uploads the uh, either it updates some kind of a database where it can store the current state, and tomorrow basically another spot instance may basically query that what is the current state, and it can resume from that state itself. Or maybe it does the processing and it uploads the log files to an S3 bucket, and whatever, it depends upon how you want to use it. So for normal enterprise applications that you want that they stay up and running 24 cross 7 365 days, for those kind of applications, of course, you would either go with on demand or reserved instances. Much better if you can commit to some instance. You get a lot of discount. On demand instances are the highest, but gives the flexibility that you can terminate at any time you feel like.
So essentially, the
Yeah.
use case for which spot instances will be used is for, say, for example, for testing, maybe we require some instances. So we just take it and we just try our testing on that.
Yeah,
Something like.
correct. Of course. I mean, if it's something like, your home environment, you want to do you want to maybe some install something and play with it. Maybe spot instance is a good idea. Normally it doesn't get taken away, just, you launch it and it just gets taken away. But in an hour or so, it may get taken away. It may happen that it doesn't get taken away even for 8 hours. So if it's just your lab
Hmm.
environment, who cares if it gets taken
They
away?
give a
You can always
notification,
start.
right, before taking it away.
Actually, earlier they didn't used to give it a notification, but I think now they have started giving it. But it's not, it doesn't give you that much time. There are ways of handling it. I think I'm not sure what time period it is, but it's not some big time period.
Mm-hmm. Okay.
Sure.
Yeah.
Yeah.
So let's try to create a EBS volume, and we'll try to mount it. And so
Shubham, what all topics are pending for today?
so
As I
what all
believe,
topics?
Yeah, sure. Actually, yeah, I had a meeting. So, yeah, if probably I was thinking we can continue by tomorrow creating the EBS volume.
Yeah,
Can,
sure. Of course, we can do that. So uh, today we were planned. I mean, we have planned EBS types of EBS volumes, how to launch, how to create EBS volumes, how to attach them, and then some instance store and AMI creation. Okay, no problems. We can continue tomorrow from where we left.
Okay. Same time.
Yeah, same time. Or you guys want to start early?
I mean, tomorrow or day after
I
tomorrow?
mean, day after tomorrow. Sorry, I forgot. Okay.
Yeah,
yeah, yeah, sure.
like before you joined, Shubham, I was just like, we are okay with it, but I just want like checked with Kaushik if we can start like 6:50, 10 minutes early, like we will at least get 10 minutes. So yeah,
Yeah,
that
correct.
then
Yes.
yeah, so 6:50 we
10
can
minutes.
start.
Yeah.
Yeah,
So I have one more thing. Uh, as such, today's topics are remaining, right? So can we just have a session tomorrow if everyone is fine, so that we can
yeah, I think
finish
that
off
is
to.
also
Yeah, we
yeah,
can
I
finish it
think
off.
that is also a good idea, Shubham.
Yeah,
If you
Yeah,
if you're
I'm
fine.
okay. Yes, I'm okay.
Yeah.
so
So
we can cover
So
this
today's
four
topic will be,
topics tomorrow.
yeah,
Yeah.
yeah, correct, correct.
yeah, correct. So maybe we don't have to take 2.5 hours or 2 hours. Maybe we can cover it in 1 or 1.5 hours. So how about
Okay.
Sure.
6:50 till
Sure,
8:15?
yeah.
Yeah,
Yeah,
tomorrow we can have it. Yeah.
6:50 to 8:50. Yeah.
Sure, sure. Yeah.
Okay, fine then. Yeah. Okay,
Okay,
so any
thanks.
other doubts? I mean, or shall we wrap it up for today?
Yeah, we can wrap it up. You will be sending exercise, right, to us.
Yeah,
We
yeah,
can
I
do
am
it
going to send
tomorrow
the
morning.
slide deck and the assignments.
Hmm.
Oh,
Sure.
Okay, then thanks everyone.
Okay.
Have a nice
thank you
evening.
so much, Shubham.
Thank
It
you.
was a good
Okay, sure.
session. Yeah.
Thanks,
Bye,
Shubham. Yeah.
everyone.
Bye.
Have a
Thanks a
nice
lot.
day.
Yeah. Bye. Bye. Good night. Yeah.